Episode 8 of the 31 episode series as I bring awareness to brain injuries every day during the month of March. Today we're going to talk about brain plasticity, and I'll explain what that is and how the brain heals itself after a brain injury. In the episode, I'm going to discuss brain rehab, cognitive rehabilitation, and how we can repair the damage in the brain. But prior to that, I want you to be able to understand why these techniques work. And so we're going to explain brain plasticity, neurons, and what the brain is doing to try and reestablish normalcy after a brain damage. What you learned today is not only good for those suffering with brain damage, but this is key to understand as you get older, because loss of neurons not only occurs with old age or a traumatic brain injury, any type of event where there's like loss of oxygen, exposure to stress, to small hits to the head, constantly firing weapons, explosives, being in construction, all kinds of things like that can impact the brain health and begin to kill brain cells. Nutrients, chemicals, different things can impact the health of the brain cells. This will cause a degeneration of the brain cells and result in cognitive dysfunction, motor dysfunction, and things like that. And with a brain injury, there's also secondary damage that will occur that will continue to kill more brain cells after the injury. As the immune system is attacking the damage, more inflammation occurs in the brain and bleeding starts to occur. And this can result in additional damage to the brain even after your brain injury. Brain plasticity, the brain begins to regrow new neurons to try and make new connections. Let's talk about a neuron or brain cell, what they consist of and what they look like. I sketched one out here on the whiteboard. So this is what a neuron or a brain cell looks like. It has its main cell body, and then there's these little tentacles that branch off of it called dendrites. And the end of the tails, as you see where the myelin sheath is, it goes down towards what we call the synapses. And the synapses is where it makes connection to other brain cells to complete a network. The connection between two neurons is the synapse cleft, where they connect and communicate together via neurotransmitters. The average human brain has over 100 billion of these brain cells, and each brain cell has anywhere from 1,000 to 10,000 synapses branching out. These brain cells will connect at the end of synapse cleft when two brain cells connect together and become part of a team. This is called synaptogenesis. This millions and millions of connections between one cell to the others explains why a damage in the brain to one area can impact multiple functionings of the body. These neurons require nutrients and oxygen to survive, and neurovascular coupling is how the brain cells connect to the blood vessels, and that's how they receive the oxygen. And one of the causes of the brain damage can be when this connection is lost and the brain cells are no longer getting the oxygen needed. Let me use the analogy of using a football team to explain brain plasticity. What happens when a part of the brain is damaged and you lose a certain function of the body that you need to restore. So let's say you got a football team. The football team represents the entire body. And you have your quarterback, your running back, you have all these different players who have a key role to make the team successful. Now you've lost your quarterback. Something happened, you lost your quarterback, you don't have any backup quarterbacks. So now you go on the hunt. Scouts are going out and they're looking. You're walking around and you're saying, hey, does anybody know a quarterback? We need to find a quarterback. We're hunting around trying to find that quarterback, and you're looking around, hey, can you throw a ball? Can you throw the ball? Oh, I kind of can throw a ball. I used to throw a baseball. Well, let me grab you and teach you how to throw a football. And that's kind of the same as when there's brain damage. The neurons, they're trying to reestablish connections so they can maintain that normal function. So let's say that the brain damage resulted in the inability for the left hand to move. So then those neurons are like, hey, we need to find another neuron that can help us move that left hand. So those synapses, checking out all the 100 billion brain cells and the trillions of synapses, and say, hey, can you throw a ball? Can you throw a ball? It's like, hey, I found this guy. He knows how to throw a ball. Let's try and reconnect to him and regrow and do synaptogenesis and create a new connection in the brain. So now we can eventually learn to get that left arm to work again. And that's how it works with a brain plasticity in a brain injury. And this can be done through a lot of the cognitive exercises, the therapy that you can go through to help restore that function, which we're going to talk about that in some of the other videos when I show how to help and rehab from brain injuries.